This thing is just relentless. Hey everyone, welcome back to Pine Hollow Auto Diagnostics. It's a beautiful morning, and today we have a 2010 Mercury Mountaineer that the owner says it's really annoying to drive because of this. He drove it 3 hours here, and Kevin, how annoying was that buzzer?
Extremely annoying.
Extremely annoying. So it's a pretty mint clean vehicle. This problem has been going on for a few years now, and the parts cannon has been fired. The ABS module has been replaced, and the RSC, it's like the Ford stability control system. So obviously you want to scan for codes first, and you're gonna have to deal with that with the key on. ABS is saying C2777 sensor cluster bus fault U1901 can invalid VIN mismatch because they never synced the ABS module and then battery voltage out of range. So if this fault was present with the original module and the new module, we're going to focus on these two codes. So let's look these up in service info, get a game plan, and see where this goes. This thing is just relentless. Sometimes it just goes on for minutes. So, as I often say in my videos, research is about 80% of the whole diagnostic process. You don't want to just jump in, start tearing stuff apart, wiggling connectors, especially if the problem is semi-intermittent. In this case, it's consistent, but we don't want to fix it without knowing what you're touching. So, I pulled up the code C2777, sensor cluster bus failure. Now, right here it just says go to pinpoint test G. It's a Ford thing, so pinpoint test G, right here, these are the DTCs. We do have the 2777 and the U1901. So let's read the normal operation. There's a yaw rate sensor, roll rate sensor, lateral accelerometer, longitudinal accelerometer, and contained in one module called the stability control sensor cluster. Okay, measures all these things and sends the signal along a dedicated control area network bus to the ABS module. Very key. So it's a dedicated network. And then voltage is supplied on these two circuits and a ground, and then the two wire communication. So before going through the flow chart, right here you can see that these two codes can set if the voltage sent to the sensor is out of range, or it can also be set if the CAN circuits are open, shorted to ground, or shorted to each other. So let's pull up the wiring diagram of the sensor cluster. I actually have it printed out. This is page 2. Here is our stability control sensor cluster. And as you can see, it is 4 wires. We have violet, brown, and green and violet. Those are the supply and the ground. And then these two are communication lines. We have 4 wires to work with here. The diagnosis should be pretty straightforward. You can see there's 2 intermediate connectors. You want to take note of that. And classic power and ground check, and then communication wires check. But let's see what the steps are in that pinpoint test and see if there's any specifications that we can check quickly. Okay, so just scrolling through the flow chart. Again, power and ground checks, check for voltage, should be between 8 and 17, so battery voltage there. Check the sensor cluster power circuit for an open, ground circuit. So basically all the first 5 steps you can just do with the test light. Connect from power to ground, turn the key on. If it lights up, your powers and grounds are fine. Check the dedicated CAN bus circuits for an open. Okay, now this is getting more interesting. For a short together, so these are all ohm meter checks. We don't need a scope just yet. And then, this is interesting, check the dedicated CAN bus terminating resistance. So at the cluster, you unplug it, and the resistance through the ABS module should be 120 ohms. Now, Kevin, here, you said you're an electrical engineer, or what's your?
I was a project engineer. I have a degree in electronics.
So he followed this pinpoint test G. He measured the resistance already. He said it was, what, 260 ohms?
213 or something like that.
Okay, so not 120. That's a great clue. That already saved us a lot of time. You know, we'll probably have an issue with these communication lines. But let's find this cluster and check power and ground. And then, you know, we can unplug it. It's been unplugged several times already. And hook up a scope to the CAN lines, see if there's anything abnormal, and then do that resistance check. If it's too high, we're going, you know, we have to split the circuit back to the ABS module. So let's do that. Alright, so the easiest access to this sensor cluster is from the driver's side. Just remove the little panel, a duct, and we're in. 4 wires. Let's unplug it. Just check power and ground with a test light. Make sure we have a nice bright test light, and then we'll focus on those communication wires. Okay, first check. Test light between power and ground. Turn the key on. See if that lights up. Nice bright test light. So we just ruled out 2 out of 4 wires. Let's move on to the communication side. Okay, next up, ohm meter. We're doing a resistance check on these 2 wires going all the way through the ABS module and back out. So, according to the service info, there's a 120 ohm terminating resistor right here. So we're measuring here, through this wire, and back. 135 ohms. Now, would you say that's good? Is that bad? That's pretty close to 120. And the owner, when he measured it, it was over 200 ohms. So, are we dealing with a bad connection somewhere along the line? It seems that way. So, you could continue with the ohm meter, measure from the ABS module to here, and then on both circuits see if one's higher than the other, then split it at the connectors. But I want to plug the circuit back in and use an oscilloscope to see if the waveforms are being, are they being pulled to ground, pulled to battery power, or maybe they're shorting together. Can we see something on the oscilloscope just to try it before we go unplugging these other connectors? Okay, so next step is, yes, we're going to use piercing probes to probe the wires right here. They've already been probed, so don't feel too bad about that. What is the resistance going to be if we plug that cluster in? Is it going to drop to 60 ohms? Service info does not say that there's a terminating resistor in the cluster itself, but let's check that. So we have 135 now. That's the resistance in the ABS module. And we plug this sucker in. Is that going to drop to closer to 60? It does. So terminating resistors on both sides. Now we're at 65. Yeah, let's just plug in a 2-channel scope and see what the CAN high and CAN low look like. Alright, Pico scope's coming out to play. I was going to use the little 2-channel scope, but the battery died on that. But the Pico battery never dies because you just plug it into your laptop. So, same 2 probes, CAN high, CAN low, 10-volt scale on each channel. Let's turn on the key and see what the signals look like. Okay. Let's wait for that. I mean, I don't think we fixed anything, but we'll wait for the dinger to come on. Hopefully it'll set that code again. The only thing we touched so far is the connector at the cluster. Let's see, key off. 0. Okay. Stop the recording and back up. Does this look like a good CAN signal? It looks perfect to me. Okay, well, I was hoping the resistance was going to be a little higher, as in 120. And what's going on right here? So I turn the key off. You know, we're hoping for a connection issue here, not anything too silly. Okay, so the car's not dinging. The can looks fine. Our resistance measurement showed pretty close to 120. Well, 135 is a little high. But the problem is not occurring right now. And when the customer brought the vehicle over, it was dinging incessantly. And again, the only thing we touched is right at the cluster. So, is it possible that the problem is close to the cluster? Perhaps. So far, from that fact that right now the car is happy, I think we have to go a little further. So what's the next connector here downstream? C215. Where's that located? So I already did my homework on all data. So as you can see, without service information, you would get absolutely nowhere on these modern vehicles. So that's our wiring diagram, C215. So search for C215, and let's see, where was it? Component location views. So this is the dash harness. Click on that, zoom in. C215 is right next door to the cluster. Right here is actually a better view. There's C215, and there's this C3073 stability control sensor cluster right next door. It's almost like a pigtail. And sure enough, this harness comes over here, and there's that 4-wire connector. So I don't know why they have a pigtail here. If it's not acting up, let's unplug this, do a tug test, look at our can, and measure the resistance from the connector going to the ABS module instead of from here. If it's 120, then we know the problem is right in this area, in this harness or these pins. Alright, so I unplugged connector C215, and I want to measure resistance now with adapters on this green and orange and the blue and white going to the ABS module. Plug the wires in. You can reference the wire colors from this side. White and blue, green and orange. These two pins. The other ones are power and ground. So I think the connectors are on the pins. They look fine. But we have infinity here. Interesting. Alright, so I moved the little adapter leads to the other two pins. I just want to see if we still have power and ground. Test light and a voltmeter. Key on. Test light lights up. 11.8 volts. So I know my adapters are fine. We go back to ohms. I'm going to put it on the other two pins. We should have that 130 reading. There it is. You see it with your own eyes. Open circuit. I know my meter's good. My leads are definitely making contact. It's the right size for the pins. Maybe we should go to the other side and do a tug test. Let's plug the pigtail back in, measure the resistance here. If it's open circuit, we're getting really close to the problem. This is pretty crazy. Okay, so I plugged the pigtail back in, doing the resistance measurement again. Open circuit. If we plug it back into the cluster, it's going to be 120, right? Or 125. So now we're completely open circuit to the ABS module. So let's go to the other side, see where the wires go after that C215. We have to be getting so close. You do a tug test, see what the heck is going on. We lost all continuity. Alright, so we're going to watch the ohm meter, and 124, that's the resistance of the little cluster box, so that shouldn't change, but I'm just going to pull on these two network wires. Pull just right here. Seems to be okay. Pull right here. Seems to be okay. I mean, here's the pigtail. What gives? Take a closer look at those pins. And these wires come up here, up into the dash. Yeah, 124. There's no rhyme or reason here. Okay, so I just unwrapped this little section of harness. I'm doing the check right here. Still have open circuit, so we have to go to the next connector. The next connector is C213. Let's see where that lives. C213. So it's going to be driver's side, kind of up under the dash. A big bulk connector that connects the instrument panel harness to the ABS module. That's the next connector. But the fact that something changed when we were right here still makes me think the problem is in this location. Alright, connector C213. I assume it's this one. We're looking for that white and blue and green and orange, and there's definitely a little green crusty action going on here just on that bottom pin. Doesn't mean anything. It's just one pin that might have gotten a little wet. I mean, we can pull on it. Yeah, it's still solid. It's fine. Okay, so we're at this connector. The little green crusty is suspicious, but our pins are way up here, confirmed on the connector diagram. If you see, pins, let's see, 44 and 45 are going to be right here. Green, orange, blue, and white, VCA 24 and 23, just like our diagram shows. That's the right circuit. We're measuring the resistance across those, and it's open circuit. So this comes from the dash, and well, which side comes from the dash, which side comes from the engine, we don't know exactly yet. But let's plug in the box and see if our resistance goes to 120. Then we know the wiring from here to the cluster is perfect, and then we're going to focus on the wiring from here to the ABS module. Here we go. So we have our ohm meter on those two wires, and plug in the cluster box. Beautiful, 125. Okay, so next step is to unplug this connector and see which way the harness goes. Either here, I think probably here it goes towards the engine, and this side comes from the dash, but let's just see. If the cluster's on this side, the resistance will stay at 124 when we unplug this bulk connector. Let me unlatch that. Alright, so connector's unplugged. It doesn't look pretty. There's definitely, this is probably a constant battery power, and that's where the green crusties are just growing 24/7. But our pins are way up here. They should not be affected by this. And the ohm meter went to open circuit, so we know that the box, the sensor cluster, goes that way. So the dash harness comes in here, we're 120 that way. Now we're focused from here to the ABS module under the hood. Pretty crazy. I didn't think we were going under the hood. Alright, let's do a visual inspection on the harness that comes under the hood. So it goes through the firewall, down here, let's see right there, new brake lines, kind of flattened out under the battery. See, someone's been here, the insulation's off, the wires are just all exposed. This is a corrosive environment. You got battery acid, salt, whatever. Those wires right there are the communication wires. You can see the twisted pair. Then it comes down here, kind of gets pinched between this ABS module. There's a rusty whatever frame bolt. You can see the harness is kind of, might be rubbing through. Not does not look like a friendly environment. And the ABS module, obviously the big connector, is right there. Okay, so battery's out. Just doing visual on this wiring harness. This corner right here I don't like because all the salt and corrosion and all this crap collects and the wires just soak in it. But it doesn't mean our problem is there. Here's the two CAN wires, and you know, they're still in one piece. So I got the ABS module unplugged, and we're doing a resistance check from that dash bulk connector to the ABS module. So the yellow leads are CAN high on either side, and the black leads are CAN low on either side. So CAN low is perfectly continuous. 0 ohms, fine. Let's measure the CAN high from here to here. So the meter is sending out over there. It's going through the wire back on this yellow lead to here. 0.4 ohms. So from this connector to the dash connector, everything looks fantastic. I mean, this is very surprising to me. What are the chances that the ABS module connector is messed up? Let's unplug it, plug it back into the ABS module, and then just measure from the dash connector again. So from here to here, it should say 120 once I plug in the ABS module. And the owner said there was some brake fluid leakage around here, but you know, everything looks pretty okay. I'm going to plug it in, and we should see 120. $125. Rock steady. Just going to plug it again. Slide it out. 0. 150. Ooh, infinity. Want to keep sliding it in? 136, 144, 150, 125. I don't like that. Usually when the pin starts to make contact, the resistance should be, shouldn't change, should be good. So I'm going to slide it out again slowly. Mega ohms, slide it in. 125, slide it in a little more. There, I don't like that. I'm not touching it. It's all over the place. Slide in a little more. 128. 125. So if it's 125, I should be happy, but what the heck? What's going on here? Is that connector seating all the way in? It looks like it is. Back to 125. Now see, if I mess with it, if I press it, it should not change whatsoever. Right there. Well, what's that? Infinity. I'm just pushing this with my finger sideways. We have infinity. So we're right at the problem. It's either a pin fitment issue or the wire down, right past down the connector is not happy and something's going on. We could find those wires, do a little tug test. We could do that. So infinity, 125. 130. If I just slightly tweak it sideways, we're open circuit. So this truck, you know, is riding down the road, bouncing around. This harness is wiggling a little bit. No wonder it's setting this fault. So I'm going to do a close visual on those wires. If the wires are good, we'll check the pins, terminal fretting. Crazy.